Hi everyone. So 10-2 is about the specific conic section called a parabola. And yes, you've seen a ton of parabolas so far, but believe it or not, there's still more to learn about them. You've learned about parabolas, you've graphed them, thinking about them as quadratics, but now we're going to look at them specifically as a conic section. There's more things to discover about that. So your activity yesterday, what I hoped for you to understand from it is that each point on a parabola is equidistant from that point that we labeled F. F stands for focus. And this line down here, this line is called the directrix. So every point on the parabola is equidistant from the focus and the directrix, including the vertex. So this distance from the vertex to the focus and from the vertex to the directrix are also the same. And that distance is called C. C equals the distance from the vertex to the focus. And that number C is really important in being able to graph and describe these parabolas. So that means that this focus right here is at the point 0C, and the directrix, it's directrix, not directric. Directrix, this is at the point, it's the line y equals -C. So this focus and the directrix are really important parts of the graph of the parabola. And your graphs are always going to be including the focus and the directrix. So standard quadratic form in terms of a parabola as a conic section is y equals 1 over 4c times x squared, where c is that distance from the vertex to the focus. So I've got a couple examples of the kinds of questions that I'm going to ask you. The first one says if the vertex of a parabola is at the origin. Those are all the parabolas we're going to be dealing with for now. And in the future, we're going to deal with parabolas with a vertex not at the origin. But for now, if the vertex is at the origin and the focus is at 0, 1/2, what is the equation of the parabola? So this isn't asking for any kind of graph, but sometimes it helps me to picture what's going on if I draw a graph. So here's my graph. The focus is right here at 0, 1/2. And remember, the focus to the vertex is the distance C. And you can also think of the focus as the point 0C. So that tells you that C in this case is 1/2. And that's important for writing the equation because now you can put 1/2 in for C and simplify. That's the equation of your parabola. So y is going to equal 1 over 4 times 1/2 times x squared. And that's going to simplify. 4 times 1/2 is 2. So this is going to be y equals 1/2 x squared for the equation of that parabola. For the next example, now you have the equation of a parabola and you're going the opposite direction. You have to find the focus and the directrix. So it's y equals 6x squared. So I'm just going to sketch that just because I'm a visual person and you don't have to do that if you don't want to. I know it's opening up because it's positive. Same rules for that still apply. So here's just a sketch of the graph. And I want to find the focus and the directrix. So the focus is right here. And then the directrix is going to be a line below the parabola. So I need to figure out what C is because C is the distance from the vertex to the focus. So this equation is in the form y equals 1 over 4c x squared. That means 1 over 4c is equal to 6. So if I write 1 over 4c equals 6, then I can solve this equation for c, and that's going to tell me how far the focus is from the vertex and how far the directrix is from the vertex. So to solve this equation, I'll multiply both sides by 4c. So 1 equals 24c, divide by 24. So c equals 1 over 24. So this focus is at the point 0, 1 over 24. Clearly my graph is not to scale. And the directrix, this line down here, the distance from this line to the vertex is also 1 over 24. So the directrix is going to be the equation y equals negative 1 over 24. There you go.